Force of gravity. Let's learn about it. That's a good sound. You have these slides, so feel free to follow along on your phone or whatever. We're going to talk about the force of gravity in specific. We're learning about forces, but gravity's all around us, and it's really easy to use, and it's a nice constant acceleration. And there's lots of problems that we can do with gravity. So we're going to kind of make that a unique situation. Okay, and we're going to focus on it for a bit today. If I hold up a hammer and a book, do they feel gravity? Do they stick together?
Probably.
If you put these two objects in space, far away from anything else, and you let them just sit there still, at first nothing will happen. You won't see anything. But over about 3 days, these two things would come together and slowly bounce and stick together. That is the reason you are alive. Because matter is attracted to matter by gravity. The reasons for this are very interesting, but I'm not going to go into that today. Suffice it to say, any two pieces of matter will be attracted to each other. If you were wondering about that person sitting beside you, yes, you are attracted to them. But not very much. Sorry about that. Any two pieces of matter, any two bodies will experience a force of attraction that depends on their masses and how far apart they are. So obviously more mass, more gravity. That's why we are actually pulled. You can feel the, well, no, you can't feel it, but you are pulled by the Earth because the Earth has so much mass, right? If you're farther away from the Earth, what happens to the force of gravity? Yes, it gets lessons. It lessens really quick, too. It's not linear. It's a inverse squared relationship. So, what's 2 squared? 4. So, if you were to get twice as far from the center of the Earth, so that's how we measure it from the center. So right now, we're on the Earth, but we're a ways from the center of the Earth, right? 6,000 kilometers or something. If you were to go twice as far, like if I shot you out into space, and you went twice as far, gravity there would be 1/4. Okay. Matthew gets it. So Matthew, if I were to put you out 3 times farther, what would the gravity be? Say that again? 1/9. Because 3 squared is 9, right? If you were a quarter out, sorry, not a quarter. If you were 4 times further out? 1/16. Yeah. You get that? So if this is the Earth, and you're here, and you have G, if you go twice as far away, you have 1/4 gravity. If you're 3 times away, you have 1/9 of gravity. If you're 4 times farther away, you have 1/16 of gravity. So if you went 4 times out from the center of the Earth, the force of gravity on you, you'd be 1/16 of your, not your mass, but your weight. Say that again. Mass, we talk about the amount of matter in an object. Really, it's the amount of resistance to force. And weight, this is really important. Repeat after me. Weight is the force of gravity. Force of gravity, weight, same thing.
Same thing.
Same thing. Okay. So, last time we had F net equals MA, yes?
Yeah.
Okay. This is the same thing. It's just that if I drop something, then it will accelerate at 9.8, right? And so we just call it this because it's so ubiquitous, it's so common in our learning of physics that we make a special kind of situation for it. Here on Earth, G is 9.8. Is it 9.8 everywhere?
No.
No. If you go to a different planet, it's going to be a different G. And I'm going to show you how to figure that out later. But for now, here on Earth, G 9.8 and downward, of course. Okay. So if you want to figure out the force of gravity on something, because we know that everything accelerates at 9.8, it doesn't have to be falling for us to calculate it. Does that make sense? I'm going to say something, I hope it doesn't sound sexist. Females make better fighter pilots.
Why is that?
Fighter pilots?
Fighter pilots.
Why? I'd love to be a fighter pilot. That looks so much fun.
Me too. I wanted to be a fighter
The
pilot.
sensation and
Yeah.
acceleration is insane.
Yeah, acceleration of mass and gravity.
So what you're saying is there should be female also.
Oh my
Female human beings have a lower center of gravity.
Oh, yeah.
And so if you go into, have you guys ever seen a centrifuge, like on YouTube or something? They put you in this bubble on the end of a long arm and it spins around. And you're like, you're sitting in the thing and you're like, you're being like accelerated so fast and you're like this, right? And what happens to fighter pilots is if you have to do a maneuver, like let's say you have to do a negative G pullover, so you're flying and somebody is on your tail and you have to do this. And you have to do it really fast to get away from the guy who's trying to shoot you down. What was that property of matter? Taylor? Say, inertia. Very good, Taylor. If you're flying forward, what is your blood doing? It's going forwards, right? And if your jet, I need a model jet. If your jet pushes up, what will your blood tend to do?
Go forward.
Wants to go this way, right? So if you're in the jet and you pull up, where is your blood going to go? Like in the body. It's going to your feet, right? It's going to go to your feet. And so they do this testing with fighter pilots to get them used to the sensation and to know when am I going to black out. Because if you have to do a negative G pullover or some other G-inducing maneuver, what will happen is, the first thing that happens is your vision goes black and white.
Yeah.
Because you're losing blood in your eyes and your receptors stop working. And so everything goes black and white. Then you see spots.
scary as hell.
Then everything goes red. Goes a red tint. And then pop. I don't know if I have those steps properly, but there's a bunch of things that happen with your vision, and then it goes like this, and it goes, and you go out. Kai.
Is the red tint from redshift or not?
That's a good question. I'm not sure about that.
What's redshift?
Oh, that's a big topic. I can't get into that right now. After I finish the video, I'll do a little video on redshift. It's a very good teachable moment. Do you know the Doppler effect? Do you know what that is?
The what? Is it the sound
This sounds
effect?
familiar.
I'm
Well,
so
is it-
conflicted.
Is
I
it,
don't know what to do.
is it the sound effect? When sound-
Yeah, like you know when a car goes by?
Yeah. Yeah. Yes.
Well, that happens because the car is a source of waves. And so if I'm standing here and a car is coming towards me, let's say that you guys have a car and it's just sitting there. You hear the noise, right? Well, that sound is a wave of compressed air, and it's hitting me. But if you are driving the car towards me, then you create the wave, and while the wave is coming towards me, you close the gap. Because you're driving towards me. And then you make another wave. And so the wave length, the distance between each wave, is shorter. The wave's traveling the same speed because a sound wave is based on the air, not on the source. It's always the same speed. 343 meters per second. So if you're driving towards me, it's like, and you hear that as a high pitch. If you're driving away from me, you create the wave, it comes towards me, and while it's coming towards me, you are driving away before you create the next wave. And so the wavelength is longer. So it's at a lower frequency. So that's why you hear that. The car is not changing the sound. It's just that the wavelengths are changing. This also happens with light. Except we don't hear pitch with light, we see color with light. So if light is moving away from you, if the source of the light moves away, all the colors shift towards red. Because red is the longer wavelength. This is one of the pieces of evidence we have that the universe is expanding. Because all the light we see from faraway galaxies and stars and stuff, it's all shifted towards the red.
Is that what redshift is?
Pardon me?
Is that what redshift is? Or is
That is what redshift is, yes. Yeah, and Kai brings it up because he's interested in astrophysics, which is cool. Okay, I'm going to stop there. Earth. Sea level, G, 9.81 meters per second squared. This varies a wee little bit around the Earth, depending on what's in the crust and the core. And if there's a big piece of iron underneath, you get a little bit more gravity because there's more matter. Up on Mount Everest, it's a little bit less because you're farther away. On the moon's surface, G is only 1.6. It's a lot less. Not only, that's weird, right? Because the moon weighs a lot less. It has a lot less mass. But you're closer to its center because it's smaller, right? Jupiter, G is 24. So you're 2.5 times heavier on Jupiter. So I weigh 80 kilograms. Well, no. I weigh 800 newtons. On Jupiter, I would weigh 2,000 newtons. So I would feel like I'm 180 pounds. Who knows their weight in pounds? You don't have to tell me your weight, but who knows your weight in pounds? Who knows in kilograms?
No clue.
Okay, so I'm 80 kilos. I'm about 180 pounds. So on Jupiter, I would be 400 pounds. Something like that. Like I wouldn't be able to walk very well. You would just be like on the surface. You'd also be dead, but you know. Anyways, okay. So different G's in different places. What, that's it? Oh, I guess that's it. There's a bunch of questions that you need to know how to do with the force of gravity. I'm going to give you a worksheet now with some problems specific to gravity. Before I hand that out, there's a couple things. If you have issues with the test or whatever, I'm going to try to help you with those today. You also have your video assignment. You remember that?
Yes, well, I don't know where we're supposed to do.
Wait, is that in
Yeah.
groups or solos?
We need to explain something.
So the video is a solo thing. I'll type something up and I'll post it. But in general, you're going to make a video 30 seconds to 2 minutes long, explaining some part of physics that you already have learned. Should I just open it? Should I make it any kind of physics?
Yes.
Okay, let's do any kind of physics. We'll allow you to get into something you're interested in. But so I'm gonna give you good marks on this because I want to reward you just for the effort of communication. But I want you to learn how to communicate. If you're the type of person who just is really nervous and stuff, there are ways around that. You don't have to be in the video. You can use digital tools. You can do the whole thing watching a hammer do something or whatever. But I want your voice in it at least, so that we can, or some way to communicate that's coming from you. Okay? I just think it's such a valuable skill, especially in today's world, to be able to communicate. So that's the point of this: is for you to get some practice, and we're going to talk and learn about better ways to do that. So, you have, when does this end? 10 o'clock?
Yes.
Well, I'm going to stop this video now.